If you cast your mind back all the way to C1, you should remember that sometimes we get statements in words which we need to encode algebraically. So we need to take a statement in words and out of it form some kind of equation or inequality. That happened with the discriminant. This time we're going to do it a little bit with differentiation. First things first, increasing. For a function to be increasing, the graph is going to go uphill. It doesn't have to be in a straight line, but if it's going uphill, then that is said to be increasing, and that happens when dy by dx is bigger than 0. So we've taken a statement about the graph increasing and turned it into some algebra. Dy by dx is bigger than 0. Decreasing, on the other hand, is obviously going downhill, so a function is decreasing if it's always going downhill, and in that case dy by dx is less than 0. Of course, we might also talk about f dashed x instead of dy by dx, so there's two other cases there. Some functions are increasing all the time, some functions are decreasing all the time, and others in the middle might be increasing for part of it but decreasing for another part. Let's take an example then. This is from the textbook, objective 9.1. It says find the values for which f of x, which is 5x cubed plus 12x, is increasing. Well, again, we have to take that word increasing and think about what it means in terms of algebra and our dy by dx. Go back to the last page. If it's increasing, f dashed x is bigger than 0 down here at the bottom. So for this question we're going to need to find f dashed x. Hopefully you can remember back how to differentiate. So 15x squared plus 12. For it to be increasing we need that to be bigger than 0. So f of dashed x bigger than 0 for increasing. We have to think which values of x is going to make that f dashed x bigger than 0. Well, thinking about what you know about squaring numbers, whenever we square a number we always get a positive answer. So 15 lots of a positive answer, add another 12 is certainly going to be positive, regardless of what x is. So this function is therefore increasing for all x